Good morning. It is no exaggeration at all to say that everything we depend on is either made from Earth resources or relies on Earth resources for its production and distribution. I give you some examples. Oil and gas. They are used for our transportation, provide 27% of our electrical power. Groundwater. 30% of the fresh water on Earth is as groundwater, and it's our supply of drinking and irrigation water. Geothermal, it's an emerging source of our renewable energy. The subsurface, we use it for storage and disposal of our wastes as repositories. We also use it for our transportation. Coal and uranium, the energy minerals, supply us with electrical power, 39% and 19% respectively. We mine for sand and gravel for our construction, and we use copper for construction and electrical and other uses. Rare earth elements are used in our electronic materials that we manufacture. Our fertilizers are mined, potassium and phosphorus. And yes, ladies, guess what? Our makeup is formulated using mined products. In the last 50 years, indisputably, hydraulic fracturing and horizontal drilling has radically changed the way we think about our own energy sources. In making a world of difference, you can read about these particular technologies. We've used the hydraulic and also for deep water drilling. We've used these technologies to be able to obtain our petroleum, 10,000 feet of water, and then 2 to 5 miles deep in the Earth's surface below that 10,000 feet of water. We have developed the continuous miner, which has made coal mining efficient and cleaner and safer for our workers. We have developed tunnel boring machines in the last 50 years. The one shown in this slide is Big Bertha, which is the largest tunnel boring machine that's ever been developed. And when you look at what happened in 1970, Love Canal was something that told us about groundwater that we did not know, and that is that we have to be extremely careful about what we put on the soil because it can pollute our groundwater. And from that, we learned how to analyze different contaminants and how they are transported in the subsurface. In mining, I would have to say there's a lot of innovation, but I'm going to point to a couple of them. One is the solvent extraction that was developed, which allows us to mine and process much, much lower grade materials for sustainable production of minerals. When you couple solvent extraction with electrowinning, it produces a copper product that is 99.999% pure. And this has led to another technology that actually Frances Arnold alluded to yesterday in her presentation, and that is that we now have developed biomining processes where we use microorganisms to actually extract certain metals. So today, 80% of our copper is still produced by conventional technologies like smelting, but 20% is now produced by microorganisms. So how did that happen? It turns out that in some small measure, it was the result of a young lady who grew up on a cattle ranch in Montana and rode her horse Betty to a one-room country schoolhouse. She wanted to go to college for one reason, and that is because she absolutely hated cleaning the chicken coop. And her mother told her that, honey, if you would go to college and if you'd marry the right man, that you won't have to ever clean another chicken coop. So she went to college, and she met the right man. He happened to be a PhD student at the time, and so together they were working on the microorganisms in hot springs in Yellowstone National Park. And it turned out that many of the microorganisms that they were studying turned out to be extremely important in the mining industry. So they got married, and they also continued to do publishing together, and also a lot of development work that eventually came to be used in producing what is about 20% of the world's copper today. For their contributions, they were elected to the National Academy of Engineering. So let's look at some of the technologies that we need in the next, and what I expect in the next 50 years. In situ mining is going to be one of the most important technologies in mining because we need to reduce the footprint that we create on the surface because of higher populations that's encroaching on mine sites. We need to, the in situ technology will also reduce the amount of waste that we have to produce. It will be safer and more sustainable. Now, we already do some in situ mining, but for many metals, we're going to have to develop new technologies that allow us to see in the underground. We already have some great technologies, but they all have limitations. Secretary Jewell talked about satellite imagery, and I've shown one here that shows where the actual vent is in a volcano. We also have ground-penetrating radar, and we can look under Stonehenge and actually find things that are under Stonehenge that we didn't know were there. We have 3D seismic technology, which has been a big help, and we also have drill bits that are intelligent drill bits. You know what the problem is with these technologies? They can't see more than a few feet in front of them in real time. What we need is a Google map of the Earth, the interior of the Earth, so that we can see the geological and structural features underground. And we need to see these things in real time. What we need is biomedical technology that's applied to the Earth. We also need to have technology where we can assess the placement and displacement of fluids, just like we do in medicine and surgery, with the kinds of precision that we can see those things. If we had that technology today, Big Bertha would not be stuck under Seattle. And apparently Big Bertha doesn't have a reverse gear, but what happened is she didn't see an 8-inch diameter steel pipe in front of her. If we had transparent Earth and we could see things that we're doing in real time, we could greatly improve our renewable use in enhanced geothermal. We could even moderate or control earthquakes. And we could use that technology for the disposal of CO2 to make a cleaner atmosphere. Thank you.